Well, I think my job is this. I should be looking at the integrand's position, asking myself two things. Number one, can I replace something nasty in there with maybe a U so that what's in the integrand's position looks easier to integrate? And number two, whatever I allow U to be, its derivative, maybe neglecting a numerical coefficient, has to be a factor in the integrand's position as well. So you ready? Let's give it a shot. Look what I have is the integral of a fraction with 1 over the cube root of something. But I gotta confess, when you look at the something, it's well, it's this in red. And you guys, I know I've made a mistake. I forgot some of the integrand's position, but so far, what technically can you say about the derivative of what you see in red?
It's 3x squared.
Is 3, in this case,
so
z
it's a
squared.
factor of
But neglecting the numerical coefficient of 3, when I see a z squared, I identify that as a factor in the integrand's position, because I think the original integrand is nothing more than this fraction right here times what you see right here in blue. And that being the case, I think a prime candidate for U sub is going to be allowing U to be equal to what you see in red, because its derivative, neglecting numerical coefficient, is a factor within, and because I think when I replace all this garbage in red with a U, I've got nothing more than something in the integrand's position that could be interpreted or rewritten as a power expression. Let's give it a shot. Let's see if this works. If I allow this, I'll suppress credits at this point. If I allow my U to be what you see in red, as Randall already indicated, I think du is related to dz in this fashion. Now diving into my integrand and committing to this particular substitution, I think I have 1 over the cube root of my u. And I think another thing for everything you see in blue is du times
1 over third.
So I'll have my du on the inside, and I guess I'll have my 1/3 on the outside. I'll pull it out. It looks nicer to me that way. If you don't pull it out, no big deal, no problem. But you have to confess, my life is a piece of cake now. Because I think I've got nothing more than 1/3 times the integral of u to a nice, clean power. And now anti-differentiating is as easy as using the power rule for anti-differentiation. I'll take my u and up its exponent by 1. I will then divide by the new exponent, which is the same thing as multiplying by its reciprocal, and add my constant of integration. Next, I will, number 1, simplify the darn coefficient. Number 2, back substitute, replacing u with its original name, which was this.
Z cubed.
My apologies, thank you. It is a z cubed. I don't know, what do you think? What about mathematical etiquette? See, I don't know. I don't know if I should throw mathematical etiquette out the window. Because, I mean, if I did rewrite it in terms of radical notation, I don't know, it kind of looks a little bit clumsy. So in this particular example, I don't know if I really care if you abide by mathematical etiquette. A lot of times I don't abide by the etiquette when I think the answer looks just too clumsy.
So it's fine like that.
Yeah, I think either one is fine. In the near future, they'll look so ugly, I will definitely not go back to mathematical etiquette. You guys help me. The ears are kind of warm in here. Did you mind it? Is it going to bother you if I open this up?
No.
Man, it's like every semester I have to go back to Walmart and find these stops. Okay. If you're happy with this, anything else? Sir.
I had 2 general questions, really quickly. One, so I don't get separation of variables. Is this just another name for U substitution?
Ooh, what a good question. No. Do you guys agree? Well, maybe I should slip in some more words. What I really mean is this. If the derivative of some function y in terms of x is equal to x squared, then I think my function y has to be this particular expression because I anti-differentiated. You guys see that? You know, sometimes what you see over here gets so complex, it might even involve some factors or even terms involving the variable y. I say things differently. So watch, I'll get the same answer, but I look at it differently. I sometimes say, well, if dy dx is equal to x squared, then if I were to separate variables, keep the dy on the left-hand side, have the dx and everything in terms of x on the right-hand side, then maybe I can integrate each side with respect to the respective variables of integration. Now, if I do this on the left-hand side, anti-differentiating an understood one with respect to y, doesn't that just give me y? In anti-differentiating x squared with respect to x, that just gives me 1/3 x squared plus z. Ah, shoot. That's exactly what I had up here. It's the same answer. I just look at it differently. I just wasted your time. I don't think I need to look at separation of variables in this example. However, when it gets more complex, particularly with expressions involving both x and y, then separation of variables is a beautiful technique of rewriting a relationship in terms of two integrals, each of which has their own respective variable integration. And when I take a break this summer session, which I will, when I take a break and talk about techniques for solving differential equations, I'll be much more elaborate in my examples.
And also, really quickly, when you're solving a definite integral, and you're doing u substitution, obviously we know that we must change the upper and the lower bounds of integration. What is the actual step in which we do that? Is that the step where we replace everything with the u values?
Yes, that's a good point. As a matter of fact, it's at this stage here. So can I just make up some numbers that are true? You know, I think when it comes to this one and this two, their meaning in terms of this problem situation is that I'm trying to, I need to change my words, I'm sorry, I misspoke instead of trying. I could interpret this question as trying to find the area underneath the curve y equals this garbage. But on the z-axis, the horizontal z-axis, z's range from 1 to 2. But jeepers, you guys, once I change the name of my variable to u, and I've got this relationship here, that means there's different scaling on this new u-axis. And what would that new scaling be when I'm trying to look for the area underneath the graph of this equation? Y equals this beast in the now new u-y plane. Well, it's going to be under the curve y equals this garbage in terms of u, as u ranges from, I don't know, got to find it, here and here. So, sir, once I change the flag to which I place my allegiance, that's when everything changes in the integrand, including the bounds of integration. Let's do it. I think if z is equal to 1, the corresponding u value is this. And I think if z is equal to 2, plugging 2 in for z here, I think the corresponding u value is this. That's when I change them, when I change everything else in terms of u's. Can I show you what annoys me when I rework in math? What annoys me is when I see people, they just change this to a u and keep it else the same for a moment. It has no meaningful interpretation. And so you want to change everything in terms of u's this semester. Next semester I'll change that. That's a little bit ballgame. That's multivariable calculus. This is just two-dimensional calculus. Am I answering your question?
Yes. Thank you.
Sir.
I had a homework question. One of the problems really bugged me. It's 1 over square root of 1 minus 9x squared.
Okay, hold on. I lost it. 1 over the square root of 1.
1 minus 9x squared.
Like that.
Yeah. I understand that you have to use the sine inverse identity, but I just had problems algebraically following the equation.
And did you get the right answer algebraic?
Looked at the back of the book, but I didn't get the right answer.
Oh.
I ended up in something else.
So do you want to see me?
Just want to see how you go through this step by step. I mean, I got the fact that you factor out a 1/3, I think, or a 3 at the bottom.
I think at this stage of the game, it just sounds so clunky. Can I show you what I would really do myself?
Sure.
I would have said this. To integrate that thing's so much easier. Oh, shoot, I can't. They're not the same, are they? I completely messed up. I replaced my 9x squared with an x squared. That's not legal. They aren't the same. But if I can somehow finagle it so that I can take this integrand right here and make it look like something like this, then I think my life would be easy. As a matter of fact, I think I can. I think I can accomplish this task. It's just that the variable is going to change its name. It's going to be something like that. So if I can make that jump, I think my life would be so much easier. Let's see if we can do it. If I were to do this, then what would you be so that this 9 completely disappears?
3x.
But if u is equal to 3x, then what would you say about u squared?
9x squared.
9x squared. What would you say about x in terms of u? What's another name for x? U over 3. What's another name for x squared? U squared over 9. Would that work in making the substitution click? If it does, hey, the consequence. What's du?
3dx.
Let's see if this works. Diving in. I've got, can I erase this? I want to show you my steps. I've got the integral of 1 over the square root of 1 minus 9 times x squared. It's just another name for x. Over here is u over 3, you said. And I guess another name for my dx is going to be 1/3 du. Sir, I'm trying to shake you up in such a way. I'm trying to show you that I'm accomplishing the task of getting rid of the darn 9 on the outside. Because now it's going to cancel with the 9 downstairs. Because I think at this point right now, I'm left with this mess. And like I was suggesting before, I really am accomplishing the task of getting rid of that factor of 9 upstairs. Because now I introduced a factor of 9 downstairs with this particular substitution. And I think my life is a 100% absolute piece of cake. I said piece of cake.
Sine inverse
In
v
sine.
u.
Yeah, and then you're gonna
Sub in 3x for u.
thank you very much. Actually, you said what was it? Was it 3x?
Yep.
You're silent. But sir, I'm nervous. You're being quiet. Am I really answering your question?
Yeah, I got with it.
Okay.
I understand it a lot better. Thank you.
Is there anything else you guys want to take a peek at?
Similar problem. This one here.
We'll turn it into an exercise so it's not a problem anymore. No, can I borrow this? Yeah. You guys, don't ever, thank you very much, don't ever write this. I know I see this in the book printed. There's something really awful about this. By the way, I'm in section 5.5. I'm taking a peek at number 43. You guys, the reason why I'm saying I've got a real serious problem with this, it's a fraction. And look what's up in the numerator's position, dx. And when you see a dx is up in the numerator's position, that means it's a quantity, and it's not supposed to be. So I would like you guys to never let me see you put a dx in the numerator of a fraction. What the author really meant is this. We've got the integral from here to here of this fraction, where upstairs and downstairs I have algebraic expressions. Okay, simple one up there is just a number, but algebraic expressions upstairs and downstairs, and I'll slip in my flag to which I pledge my allegiance. I'm slipping in my variable integration x. I use a dx to tell you that it really is a variable x that's ranging from this position to this position on the horizontal x-axis. If you want to interpret the evaluation step and integral as the Arrhenius curve. So I'm sorry, I know I haven't answered your question yet, but I need you to change the notation. So, everybody help me. What would my u sub be?
5x.
Say it again.
5x.
Why?
Because you got secant inverse right there.
Okay, my point was this, you're not making a substitution in terms of the entire expression, the radicand's
Yeah.
position. You're just simply trying to clean up that coefficient.
Yeah.
Did you guys see that? As a matter of fact, if I allow myself, let me give myself some more room. If I allow myself to let u be equal to 5x, pay the consequence. I think something nice happens. I get the integral. I'm going over some stuff. However, when it comes to this first factor of x, another name for it is
1 over 5x.
1 over
Or 1 over 5u.
5u.
Yeah.
So 1 over 5 times u gives me a factor of u. There's a 1/5 here. Can I pull out front?
Sure.
But if I pull out front, it's 1 over 1/5. It's not just
That's
this.
5 over 5.
Well, eventually,
Yeah.
I'll show my steps. Now, when it comes to this radical, when I replace that x squared with the equivalent expression u squared over 25, here's what I get. Oh shoot, I messed up, you guys, I'm not done. I forgot my dx. So, another replacement. What's another name for dx?
1 over 5 du.
1 over 5 du. I'll put the 1 over 5 up front. Now, I think I get cancellation all over the place, number one. Outside the integral, complete collapsing. But even on the inside of the integral, within the integrand's position, even the radicand's position, I think I'm really left with this. Oh, but shoot, we have an omission. Technically speaking, I don't have my bounds of integration. Let's put them in. Is that 2 over 5 root 3? And 2/5?
No,
You can know one.
because you have to multiply them by 5. So it's going
Well,
to be...
I'll do it in my next
yeah.
step. So over here I have, yeah, I can't do it in my next step.
Yeah.
Remember somebody just asked me, when do I change my bounds of integration? Look, I replace x with u everywhere in the integrand's position. That means my bounds of integration have to change at this stage of the game as well. Do you see my point? All right, I really blew it. I can't wait. I got to deal with it now or put in question marks and back substitute at the end. Let's change things. If x holds the value of this number right here, and pick it up off the ink board, slap it in for x here, I think the corresponding u value is the same as I have there, being multiplied by 5. Likewise, replacing this x value with, well, the value in the upper bounds position, that means I get 5 times 2/5 gives you the corresponding u value. Now, this is going to give me these same bounds of integration. They're not changing. And now, if I make another u sub, let's use the letter z. What am I going to replace with z? What is z going to represent? Just to make this integrand look nicer to evaluate. What is it going to be?
Squared minus 1.
Is it?
Why are we doing z?
We're doing what?
Why are we doing z?
Well, I like to make a z sub to make the integrand look nicer. That's what u subs are all about. So I can rewrite the integrand to make it easier to anti-differentiate.
That is easier.
Good.
Easy to introduce.
There's no need to go any further. The point is, my first u sub allows me to rewrite this integrand in such a way I can just relax, kick my feet up, and rattle off the top of my head an antiderivative for this beast. What would it be?
Secant inverse of u
The inverse secant of u.
plus c.
Well,
or on the bound of
plus c is
2
fine.
to...
Plus c is fine. I just omitted
It's-
because
yeah.
it cancels itself out. Oh no! Did we just make a mistake? I thought there's supposed to be an absolute value bar here.
Yeah.
That's what I'm saying, that's where I got confused, because I got secant, and
Yeah, do you
somehow
think
it's
there's a typo in this question? I asked, do you think there's a typo in this question? I can ask it a third time.
Yes.
No, there's no typo. Technically speaking, oh, this interval, u's always positive. That's why he didn't put it in. Do you see my point? For these particular values for u from here to here, everything's positive anyway. That's why he omitted the absolute value bars. Am I making you happier? Okay. Oh, by the way, I still haven't answered the question. I guess that gives me the inverse secant of 2 minus the inverse secant of 2 over root 3, or shall I say, I can say it again,
Pi over 3,
pi over 3 minus,
pi over 6,
or shall we say,
pi over 6.
I like it. Man, you guys are quiet. Do you like it? One person says yes. I forget to turn on the computer. Oh, everybody forgot to turn on the computer. Guys, hit me up. Anything else in the homework? If not, Risa, if you're interested, you don't have to, but there are some seats